Let's try to conclude this video series on deep learning method on point cloud data domain. We have discussed 6 important paper. We start with discussing this PointNet, which is the pioneer of 3D point cloud backbone that address the permutations invariance of the point cloud data. And then the second paper, we have discussed the PointNet++, which is the improvement of this PointNet by improving the local features extractions that's considered the neighbors and also the hierarchical feature extractions to extract multiple scale. And this is very useful for point-wise recognitions. For example, when we do the semantic segmentations, we will classify for every point in the point cloud input. And then in the third paper, we also have discussed the canonical capsule. And this is very important because this addresses important property in the point cloud understanding, which is transformation invariant. So no matter the transformations we apply in the input, like the scale, the pose, or the translations, this method will canonicalize all the input into canonical coordinate. It means that the canonicalized input will be in the same scale, in the same pose, and also in the same of origin. And then in the next paper, in the fourth paper, we also have discussed the very important research directions, which is superpoint in the point cloud. And this is a simpler representations of the large-scale point cloud. For example, if we have like 1 million, typically the existing method will again split the large point cloud into smaller point cloud and infer this independently. And we have some drawbacks. And in this case, this method will cast or will formulate into composition of superpoints, where every superpoint consists of homogeneous point. It means that consists of the same semantic. So instead of doing the segmentations for every point, we will do the segmentations for every superpoint, which has the much smaller number than the original point. For example, we have original 1 million point into, let's say, 1K superpoint. And then the fifth paper, we have discussed the point clip and also ULIP here. We start to consider another multimodal data. In this case, we use the image and also text to recognize the 3D. In this case, we do by transferring the 2D knowledge in the foundation model into the 3D recognition. In this case, we do not require 3D label to do the 3D recognitions. And then in the last paper, we have discussed also one of the popular applications, which is point cloud generations. In this particular video series, we have discussed this paper, de facto, that give the control ability to control the style of the generated result and also the size of the generated result. Yeah, I think that's it. And this is the original reference that I used to make this video series. If you want to dig more details about every method, you can directly read their paper, or you can also jump to their corresponding code base. That's all. I hope this video series can provide you a strong understanding if you want to catch up with the research in the point cloud data, or if you want just doing engineering project that's utilize a state-of-the-art method in the point cloud data. I hope this video series can give us a strong enough understanding. And yeah, thank you for watching this video series.